Welcome everybody to this video on selection sort. So before I jump into the coding aspect of it, I'm just going to start with a visual example. So selection sort works by looking at a list such as this one, and it is going to order the numbers by finding the smallest number and swapping it towards the front of the unsorted portion of the list. When we start off, the entire thing is unsorted, so what I'm going to do is keep track of the first index in my unsorted portion, so my 6. And that is currently my smallest element. However, it will not be. As you look at the other numbers, it will definitely not be by the end of this. But what we are going to do is look at the next index, 4, and we are going to check if it's smaller. If it is our new current smallest index, which I am going to show by green. Next, I'm going to look at the next index of my list, 1, and you'll notice that is smaller than my current smallest. So I'm going to replace it and make it my new smallest value. I'll look at the next value, 3. It is not smaller than my current smallest, so I will just go on to the next index, 2. 2 is not smaller either, so I will go on again. And 5 is also not smaller. So now that I have reached the end of my entire unsorted portion, I am going to swap my original starting index with my smallest index. Now I have a left side beginning portion of one element that is already sorted. So my next time through, I'm going to start on the second index, 4. This is my current smallest, so I will compare it to my next index in line, 6. 6 is greater, so I will move on and not do anything with my new smallest value. 3 is smaller than my current smallest, 4, so I will make that the new smallest value. 2 is less than 3, so I will make it the new smallest value. 5 is not smaller than 2, so I will keep the value at 2 and do nothing, and instead get to my end of my list, and since I've reached the end, I will swap my smallest with my current index. You'll notice now that my first two elements of my list are now sorted. Now we'll start at the 6. I will look at the next value, 3. 3 is smaller, so I will make that my new smallest value. I will continue on to 4. 4 is not smaller. I look at 5. 5 is not smaller. I have reached the end of my list. I will swap my smallest and my current index of 6 and 3. Now, 1, 2, and 3 are all sorted. I will continue on, starting at 6 again. Since 6 is greater than 4, I will make 4 my smallest value. I will move on to the next index, 5. Since 5 is not smaller than 4, I have reached my end of my list. I have not changed anything. I will swap my smallest and my starting index of my unsorted portion. Once again, I will move forward. 1, 2, 3, and 4 are all sorted, so I will start at 6. 6 is greater than 5. Therefore, 5 is my new smallest, and I will swap the two values. Now, I will not do anything on my last part because I do not need to check the last value of my list. It will always be sorted due to swapping, since everything before it has already been sorted. And this is how selection sort works. We will now move on to the coding portion in Java. Okay, now let's look at the coding portion of the selection sort. So what we are going to do first is we are going to create an unsorted array, just like we have in previous ones. It'll be an integer array since we want to sort numbers. Keep in mind, selection sort does work on anything. It's just that you have to make sure that you tailor it appropriately to whatever it is you are sorting. If it is words, you need to make sure that you are tailoring it towards letters and characters. If you're doing numbers, it's like this. Anything can be sorted. You just have to make sure you create the appropriate sorting parameters. So let's get a look at selection sort here. So the first two things we're going to need are a way to keep track of the smallest numbers index, as well as a way to keep track of each variable when we want to swap. So we are creating smallest index for the first one and temporary variable to be used when swapping. So let's start off with our for loop that we're going to start with. So keep in mind, for selection sort, we are going to start at the first index by using I is equal to 0. However, we are going to stop our loop one before the end, since when we get to the very last number, it should already be in the correct place due to all the swapping. So what we're going to first do is set smallest index to I, in other words, the first index we are going to look at. This is because we want a placeholder for our smallest index, also because smallest index could be the very first element inside the array, especially if it is already sorted. Next up, we're going to create a second for loop. This for loop is going to start at one more than smallest index, since we already have that number, and it is going to stop at the very last character in our array. This is because we want to check everything that hasn't been sorted yet and find the smallest number amongst them. So then what we're going to do is add an if statement inside of there. Our if statement is simply going to check if the value at our current index is less than the value of our smallest index. If it is, this means that we need to replace the index of the smallest number, since it is now the current index, by replacing smallest index with j. When we finish this loop, this means that smallest index will always be the index value of the smallest value inside our array. So what we need to now do with that smallest index is swap it with I. In other words, swap it with the sorted portion of our array. So in order to do that, we're going to use temp variable. We're going to assign that to smallest index. We're then going to replace smallest index with the value at I. And then we are going to replace the value at I with temporary variable. This is the standard procedure for swapping a variable in any language besides perhaps Python, which has an easier way of doing it. Okay, so this is all you really need to do for selection sort. I'm going to print out the array here to show that this actually does sort the array. So if I run this, you'll notice that I get a completely sorted array here as my result, compared to the array up here, which was completely unsorted.